So, the idea of making a good design in flowcharts is we're going to have to take it step by step. So, what's the first thing that happens when you play Connect 4? Well, the game is going to start, right? So, we're just going to, click and drag one of these circles in here. I'll double click it. It's start game, So, and then going from start game, what winds up having to happen? Just going straight from start game, what is the very first thing that happens? You have to decide who's who, right? You have to figure out, who is playing, right? Now, in this situation, we're going to assume that we have two human players. We're not going to go into computer AI or anything like that. It's going to get too complicated. It's going to bog us down. We're going to assume that player 1 and player 2 are sitting there right next to each other, but they're playing in front of a computer. So we're playing a computer version of Connect 4. So we're going to just input stuff, and the computer's going to export out what it is we did. So, first things first, we pretty much need to, what's going to happen? What's the first thing someone does with Connect 4? They take the coin and they slot it in the slot, right? They need to determine their row. So, in other words, we're just going to click that parallelogram, and we're going to go, what do they do? Okay, so, select column. I'm hoping I spelled column correctly. I'm pretty sure it's only one L. But, one moment. Just to be safe. Yes, it is in fact one L. So, select column. So now, a player has selected a column, and there's like 7 of them across, right? So, now, there's a lot of things that's going to wind up happening in a row here, but it's so quick, it's in the blink of an eye. And we need to break this down step by step by step. So, what questions do we need for this selecting column? Okay, so let's make a few questions here. Well, first off, actually, let's just highlight all these guys. Turn them yellow there. So, we need to know, is this move valid? Is move valid? Is this potentially a move that you can do, or is that column already filled up? Because what happens in Connect 4 if you fill up a column? You can't put any more chips inside that column. So, what else do we need to do? We need to figure out, whose turn it is. Whose turn? So, whose turn is it? Actually, I'll rename that one. I'm going to go with, because the chips are red and black, right? Is red's turn? There we go. That'll make it a yes-no question. Instead of having a red path and a black path, it'll have a yes path and a no path. What else do we need to know? Oh, we probably need to know, did they win? Did they Connect 4? Did player win? Okay, and we also probably need to know, because what happens if no one wins, but we filled up the entire board? So, is board filled? So that's all the stuff that we're going to wind up checking just on a simple click of, we're under the assumption that we're just clicking the row that we're, going for, or the column that we're going to slide the thing in. So, all that stuff's going to wind up happening. So, first off, let's just stick with the is move valid, because that's going to be the first question that we should probably answer. So, I'm just going to simply, I could do an arrow right here, but I could also just simply highlight over top of this, just hover, I'm not clicking, I'm just highlight overing stuff, and you see how this little green ball is appearing over some of these X's. I'm just going to take from one, click, drag it, boom. And now it's connected to this. So you see I can move it over wherever I need to move it. So now it's going is move valid. So there's going to be a yes path and a no path to this. So what happens if the move is not valid? Well, we would probably just have to select another column, right? So I'm going to click out, and I'm going to go and decide that's where I want everything. I'll move the path around because it's trying to do a little bend there. So if this path is valid, no. Is the move valid? No. Select another column. Oh, let's say I select the same one again. No, it's still not valid. Still not valid. Still not valid. You have now created a pathing here that is logic based. And then of course, if the valid is moved, if the valid is legal, then we'll say yes, something else will wind up happening. What's going to wind up happening? Well, is move valid? Okay, well, we should probably figure out whose turn it is, right? So, we'll just, say... Let me just delete that. Do that again. There we go. So, is it red's turn? Yes or no? Okay, so if yes, what happens? Well, now we're actually going to go into computer output stuff here. So, we've got ourselves, if it's valid, we will... So, if it's red's turn, okay, place red chip, or actually slide red chip down hole. Let's do that. Let's just make it easy. Slide red chip into bottom available spot. Because it doesn't go and magically hover in midair in the top spot. No, it slides all the way down to the bottommost spot that's available, right? And then what else do we have to do? We have to, change to black's turn. Right? So you have to change to black's turn. Now, that's obviously what would have to happen if it was red's turn. So I'm just going to go copy and paste, because we have to do the same thing. But this time, what if it's, if it's not red's turn, it's a no. Therefore, it must be black's turn. So slide black chip into bottom. And, whoops. And then we're going to change to red's turn. Actually, I'm going to just simply put this to change turn. There we go. That should make the most sense. So, now we've got ourselves our no path and our yes path. So we've got click to drag, and then of course both of these guys are going to wind up going to the same spot eventually. So is it red's turn? Yes. Then we'll slide a red chip in and then change turn. Is it red's turn? No. Therefore, slide a black chip into bottom available spot and change turn. You see how this is generally working out? Now, once we change turns, okay, well, we also have to figure out now, did they win? And is the board filled? And, if yes, then, someone wins, and, congratulations, game over. If no, well, then they kind of have to go all the way back up to here, don't they? And, select another column, right? So, no. And then, of course, once again, is the board filled? Well, no, then there must be moves remaining, right? Because the board is not filled. So, change turn, did player win? Is board filled? So, what are the yes paths we got here? So, what are the end paths we got here? We've got, did player win? Yes. So, we've got, game over. And then, of course, is board filled? We've got ourselves a draw condition, right? Because if no one won, because if this is the... Oh, actually, I should probably even delete that. There we go. So is board filled? No. Because I can't have two no paths. I can't have a no path going here and a no path going here. I would have two no paths. It's a yes-no question. How can I go both directions at the same time? So, did player win? Yes. Is board filled? Yes. So now we've got draw and draw. As a matter of fact, let's even change the fact that this says did player win. Did player get 4 in a row? Because that's how you win. You get 4 in a row. Yes, game over. No, is board filled? No. Obviously, there must be more things more moves to do. So draw, draw, so on and so forth. And of course, I guess I kind of need to have this game actually start here. And boom. Now we're looking at this. This is essentially an entire game of Connect 4 when it loops into itself over and over again, because we're always going back somehow to selecting a new column. Is the move valid? No. Is it whose turn is it? So blah blah blah. So is move valid? Yes. It changed turn. Did the player get 4 in a row? No. Is the board filled? No. Then obviously we must select more columns. Eventually, we will either wind up with the board entirely filled and it'll be a draw, or someone got 4 in a row and it ends. That's really how it's going to wind up being. So of course you'd, put your name on this, put your name on that, tell me, what, the game is, so on and so forth. And, we got ourselves our legend. Matter of fact, you can just tell me it's a legend. Why not? And as you can see, in about 20 minutes, you can make a pretty functional flowchart that's very nice and easy to read. Now, this is pretty much looking like it's a little bit of agile right here, but it's mainly waterfall, but it's a waterfall with a split. And then it goes right back up to almost the top. But as you can see, it follows pretty much an SDLC path as well to it. So, hopefully this all made sense to everyone, but as you can see, you can take about 20 minutes and make your own game from scratch. Now, pick a simple game. Pick something like Pong, or Q*bert, or Frogger. Pick something easy with very few rules. Even if it's a board game, checkers, fine. Chess, a little bit more complicated. You now have to determine rook movement, bishop movement, queen movement, all these other sort of things. If it's a simple card game like Texas Hold'em or something, go ahead. Pick something simple that you can fit on about 1 page, maybe 2. Don't go trying something complicated like Grand Theft Auto here, because you're not going to have enough space to make anything coherent. It's going to take forever. Okay? Modern video games have like 500-page documents about all their systems and what they're doing. So, please pick something simple. You're doing yourself a favor. We're just going over the concept of being able to plug out, step by step, the path of logic a computer will take to play a game. And you notice, there's only one thing our player even does. They just select what column they want. The computer is deciding the rest via logic questions. So, remember that.